In this video, we're going to have a look at simplifying when there's more than one term in the numerator or denominator. In the first video on exponents, I mentioned that the laws can only be used per term. Here in our numerator, we now have two terms separated by the minus. For this reason, we cannot now, just because the bases are the same, add up the exponents. This means we need to make a plan to change this numerator into one term, and that we'll do by factorizing, because factorizing makes brackets and brackets make one term. Before factorizing, we are going to use the first exponential law and apply it backwards. This means that for each term in the exponent, we're going to give its own base. The first term in my numerator is 2 to the power of x plus 2, and I'm going to rewrite this as 2 to the power of x times 2 to the power of 2. For my second term, I'm going to repeat this and write 2 to the power of x times 2 to the power of 3, and also do this in the denominator, and this will become 2 to the power of x times 2 to the power of 2. This step helps us to easily identify the type of factorization. In our numerator, we now have two terms, and when factorizing, you always start off checking for a common factor. When looking for a common factor where the exponents are variables, it is important to realize that not only a base number can be a common factor, but a base number along with the same exponents. This means in our two terms, we can take out 2 to the power of x as a common factor. Even though there is a biggest common factor, I'm only going to remove 2 to the power of x as my common factor so that I can isolate the part that has the x in it. Once removed, in my first term, I'll be left with 2 to the power of 2, and in my second term, minus 2 to the power of 3. The denominator is already one term and cannot be factorized any further. Now, both the numerator and denominator have one term, so I can simplify by dividing. 2 to the power of x divided by 2 to the power of x is 1. So here we are left with 2 to the power of 2, or 4, minus 2 to the power of 3, which is 8 over 4. This can be simplified to minus 4 over 4, which in the end is minus 1. Example 2. Here we once again have more than one term in our numerator as well as denominator, and this means that I will apply the first exponential law backwards and give each term in the exponent its own base. I will do this in the numerator as well as the denominator. Now I can factorize. In my numerator, I have two terms, and these two terms have a common factor of 3 to the power of x. So I'm going to remove 3 to the power of x as the common factor, and in the first term I'll be left with 2, and in the second term plus 3 to the power of minus 2. In my denominator, I also have two terms, and these two terms also have a common factor of 3 to the power of x. I will then remove this 3 to the power of x as a common factor and be left with 2 times 3 in the first term and minus 5 times 3 to the power of negative 1 in the second term. Because I now have one term top and bottom, I can simplify by dividing. Next, I will rewrite and simplify the numerator, and this will give me 2 plus 1/9. Just a reminder that 3 to the power of negative 2 can be rewritten as 1 over 3 to the power of positive 2, which is 1 over 9. This numerator should now be divided by the simplified denominator, and this will be 2 times 3, which is 6, minus 5 multiplied by a third. It is important to note that the negative exponent in the numerator did not move to the denominator. The reason for this is that we had more than one term. Then I can only use the laws in the term that it is, and that is why in that spot it changed to 1/9. The same applies for the -1 exponent in the denominator. The numerator now simplifies to 19/9, and this needs to be divided by the denominator, which can be simplified to 13/3. This means I have 19/9 times by 3/13, and if I now simplify and then multiply, I will end with 19/39.